Hello, everybody. It is our pleasure to continue this symposium about environmental sustainability in tropical regions. We have some guidelines for the people, both in person as virtually. Today is our second session. Yesterday, we worked on the challenges that we've found in different basins at the global level. We saw some different examples, including Chilean rivers, Brazilian rivers, Colombian rivers. And today, we're going to learn a little bit more about some management strategies that have been developed at the global scale. The people that are going to be with us as our moderators for today's talk are Andrew Wolves, represented the University of Southampton in the United Kingdom, and Hector Vera from the Ministry of Environment and Sustainable Development of Paraguay. Let me remind you that tomorrow we're going to have a talk regarding restocking. So let's begin this session with an introduction from Andrew.
Okay, a warm welcome to day 2 of our symposium on environmental sustainability and hydropower. Just to quickly introduce myself, my name is Andy Vowles. I'm a senior research fellow at the International Centre for Eco-Hydraulics Research at the University of Southampton in the UK. So yesterday, we heard a lot about the big problem that we are facing, and that relates to the fact that the freshwater fishes in South America, but also Africa and Asia, are of huge ecological importance. And this is owing to their very high levels of abundance, species richness, and/or levels of endemism. They're also of huge social importance, and this may be because of their contributions to commercial inland fisheries, or equally because they help support livelihoods by contributing to smaller artisanal fisheries. Despite the ecological and social importance of fish within these regions, they face a number of large threats as a result of human activity, but not least of all because of quite rapid and widespread development of hydroelectric power. So that's the problem that we're facing, and within the context of this problem, we heard yesterday a lot of talks about some of the specific challenges associated with improving the sustainability of hydropower or lowering impacts to fish and fisheries. In the symposium today, what we're going to do is move on with talks that are focusing more on what some of the management strategies or what some of the solutions might be. So this symposium is co-hosted by the SHAASAN network. So SHAASAN stands for Sustainable Hydropower in Africa, Asia, and South America network. And on the slide here, you can see the key aims of this network. The third aim here, I think, is of particular relevance for this symposium, which is to disseminate knowledge and build research capability between the global north and south, but also of particular importance is between different regions within the global south. Before we get started on the main talks for this afternoon, I just want to provide a really quick example of how the network is helping to achieve this or work towards this third aim. So towards the end of 2021, members of the SHAASAN network were made aware of a symposium that was being run by the Royal Academy of Engineering in the UK. The idea behind that symposium was to bring together interdisciplinary teams to try and tackle global challenges, particularly those related to solving the biodiversity crisis. A number of members of the SHAASAN network attended this event. It enabled us to develop a project and bid for some funding to work together. This was the team that was developed. So it included myself from the UK, Luis Jimenez from here in Colombia, but also, as you can see, some representation from elsewhere in South America, but importantly, with collaboration in Africa and Asia. The project that was developed was called Fish for Peace. And the reason for this was the idea that when we have healthy populations in our rivers, then there tends to be food and income and hopefully peace within the local communities. But the idea behind this project is to collate historic data and information at 4 different case study hydropower projects. The expectation is that some of these case studies will be relatively data rich and others may be more data limited. But this will enable us to provide some insights into, firstly, some of the challenges of simply identifying what the impact of hydropower developments can be on fish and fisheries. But secondly, to enable us to provide some more focused recommendations for priority research to assess impact, but also to try and mitigate some of those impacts as well. Another key aspiration of this project was to get people from different regions working together to see what some of the common challenges, but again, what some of those common solutions to this problem might be. And that could be in terms of hydropower planning and operation, or development of mitigation technology, or other management strategies besides. And management strategies is what we're going to be turning our attention to and focusing on in the symposium today. So this slide here just shows our lineup of speakers for this afternoon. So we have some good geographic spread with our speakers, some good representation from academia, but also some talks that will give the industry perspective as well. And today we'll finish with a discussion session that will be led by Professor Paul Kemp and Dr. Hector Vera. So Hector is the lead of the SHAASAN network, and Paul Kemp is the co-lead. So in that final discussion session, they'll really value any input from the symposium participants, with the aim of providing some suggestions on future directions for improving the sustainability of hydropower, specifically relating to fish and fisheries. Okay, so I'm going to stop sharing my screen in just a second and then introduce our first speaker for today. Just a quick reminder before I do that, for the speakers, you have 20 minutes. That's 15 minutes for the talk and then around 5 minutes for questions from the audience. If there are any questions for our speakers, then please put it in the, use the chat function in Zoom. But also for people that are here in the room, if you have any questions, then please feel free to raise your hand and we will select people to turn their cameras and microphones on and directly ask questions to the speakers. Okay. So our first speaker today is Dr. Gordon O'Brien. Gordon is a professional scientist and senior lecturer from the University of Mpumalanga in South Africa, and also the director of Rivers for Life, which is a research organization that provides water resource management and conservation services throughout Africa. And Gordon will be giving us a talk today on environmental flows. So Gordon, I see you've already managed to share your screen, so the floor is yours.
Great, thank you. Can you hear me clearly, Andy?
Yep, sounding good.
Fantastic. So thank you everybody for this opportunity to present this to you today. I'm going to present what we are working towards, or how we are working towards what is good practice environmental flows for the sustainable development of water resources. And it includes hydropower and other developments, which I hope we'll be able to demonstrate.
Gordon, if you're able to turn your camera on, that would be fantastic as well.
Okay, I can, I'm sure I can do that.
Perfect, yeah.
Okay. I can't see myself. I hope I'm in the shot, but we'll give it a go.
You are, yeah.
Great. So I'm going to start with the definition of environmental flows because there's some uncertainty with what we're referring to. So environmental flows describe the quantity, timing, and quality of freshwater flows, and that includes volume, timing, duration, and frequency of flows and levels necessary to sustain aquatic ecosystems. So we're interested in the amount of water that's needed to keep a system functioning, and that includes maintaining its biodiversity. And on the right-hand side, we're trying to represent this picture of a system. So we not only in environmental flow context consider the ecosystem itself disconnected from people, but that people are a part of the system. And in this context, the system needs people, and people definitely need the system. And then importantly, we are referring to those flows that are required to keep that system functioning, and that in turn supports human cultures, economies, livelihoods, and well-being. In some parts of the world, like in South Africa, where I'm from, we include basic human needs as part of the environmental flows, but in other parts of the world, they just really focus on the requirements of the ecosystem to keep the ecosystem functioning. And we consider this to be a type of control. So where do we use this, and where is it important? So if I could look at a basin, a shared basin, such as this example of the Nile Basin in Africa, you can see the idea is that if you could put all the water that is available, that flows throughout the year, into a beaker or a glass, you could see that we have these different volumes of water. And if you could audit the amount of water that's available, you could see that some portion of the water that I've represented here in green would be considered to be the amount of flows required to sustain the ecosystem. And then thereafter, we would have flows that we could allocate. And what we're interested in is trying to determine where are the environmental flows being provided, where are they not being provided, and how can we use this approach to allow us to link all of the different users together and ensure that the basin as a whole is being used in a sustainable way. Okay, so to add to that, this is again an example of the amount of water that's available in a particular environment. If I could put it all into, say, a glass. So the environmental flow is that portion of flows that exists in the system related to natural flows that are required to sustain the system. Now, the environmental flow portion can differ, and it can differ based on the vision or the balance that stakeholders decide for that particular resource, whether it's being allocated for a high protection focus or a high utilization focus. The actual portion of the environmental flows can change slightly. But remember that in a catchment context, in some areas, if you're going to allocate a resource for high use, you would have to then offset that high use and allocate high protection in other areas, so that on a basin scale, on a holistic scale, you can get that sustainable balance of flows. Okay, so that's what we're working towards. The challenge is, how do we get there? Here we go. So environmental flows and the science behind environmental flows has been around actually for quite a while, particularly from the 1990s. And there are four main categories of environmental flow determination methods: holistic methods, hydraulic rating methods, habitat-based environmental flow assessments, and then of course, holistic environmental flow assessment methods. And they're progressive, and you can see the amount of time and resources required and the different information requirements. You can see, for example, the data requirements of holistic methods are much greater than other methods. But what's important is, as the need for confidence and the importance of the resource will generally affect the type of method that will be suitable for application. And what we've advocated is that if a state or a region is going to be interested in making sure that the resources being protected on a large transboundary scale, and the regulators who are responsible for that resource should be working towards holistic environmental flow assessment methods. An example of what they look like. So this is from the Limpopo Basin in South Africa. So you can see this is a massive shared basin or catchment area that is shared between Botswana, Zimbabwe, Mozambique, and South Africa. And what we would like to end up with is this type of idea of, for different reaches of rivers throughout the whole basin, and looking at the integration of the basin and synchronizing these requirements, how much water is required for these different parts. Sorry, let me just move my away here. So how much water is available in the resource, what water is required to maintain drought flows, base flows, the flood requirements, and then what is the total requirements. And you can see that this total requirement can vary quite considerably based on the type of resource, the perenniality of the resource, and then of course where you consider different visions for different parts of the basin. You can see some areas have to be allocated for with a high protection focus, where others can be allocated for relatively high use. But this is ultimately what we're getting at. We're trying to get to the point where we can determine how much water is required and how much water is required at different times of the year to make sure that those ecosystems are maintained in a sustainable way. In order for the environmental flows to be implemented, we provide these requirements on a flow duration tables, or this format generally. And this is something that hydrologists can use to determine what is the average amount of flows required to be maintained, what is the minimum, what is the maximum. And this is just base flows, but you could include the flood flows as well to determine exactly when and how flows should be provided in a particular resource. Okay, we published 2 papers that would be of interest to you. And I'm just going to give you quick highlights of those 2 papers before I just show you how we've done, give you a case study that we've kind of carried out in Africa. The first is The Nature of Our Mistakes, From Promise to Practice, Water Stewardship for Sustainable Hydropower, specifically looking at hydropower as the major developer. And here we proposed or presented aspects of the potential hydropower development in Africa. And I think this is something that the SHAASAN group has highlighted, that Asia, Africa, and South America in particular are areas that are highlighted for new development, and what are the associated risks and opportunities with this development. How would we look at the management of water resources? How would we plan for sustainable development? And that's where environmental flows fit in. And we presented that in detail there in order to ensure that we provide sufficient protection measures. And we did then propose from our review and from the different participants who attended this workshop that there should always be a top-down approach where we're looking at the region, who is responsible, who are the stakeholders who are interested in sustainability over a large transboundary area, but then from a bottom-up approach, what can you do on the ground? What is the type of information that you need to then be able to generate these environmental flow requirements that can lead towards sustainability? The second is a paper that we published specifically targeted to support Uganda with their developments, also with hydropower development, and this was titled Good E-Flow Practices for Small-Scale Hydropower. And here again, we highlighted the value and the importance of environmental flows and how they can contribute to achieving that balance between the amount of water that should be available for use and the amount of water required to protect these resources. And what was really interesting in this case study was we demonstrated all aspects of flows, not only the volume of flows, because a lot of people think that that's all you need to maintain where you're working with environmental flows, but also importantly, the timing of flows and the importance of hydropeaking or the impact of hydropeaking, the duration of flows related to cues and seasonality and how the system may respond to alterations in the timing of flows, and then importantly, the frequency of flows as well. So we tried to unpack with these case studies and some of the work that we've been undertaking what we would propose to be good environmental flow practice. And as Annie presented, what we're trying to achieve with this is that we understand the need for built infrastructure. And if we're going to build a dam, for example, for hydropower and irrigation, we know that what the resource looked like before the development and or upstream of the development will be very different. But is there an opportunity for us to ensure that the way that we manage the releases from a facility and or the receiving environment downstream of this dam in a way that can ensure that those processes are still maintained, and that instead of going from a situation where we've got the previous socio-ecological value of the resource and the ecosystem, we can move to, there is the potential to move towards a post-dam situation where we can increase the socioeconomic benefits without sacrificing the environment. And I'm sure most of you agree that that's what we're aiming towards. So in our context, just to give you a quick idea of how we carry out holistic environmental flow assessments. So if we determine this for a reach on a particular reach scale, and we use reaches and multiple sites throughout a basin to represent the basin and linkages between the basin. And that's very important from a fish migration perspective, for example, where you need to maintain connectivity between 2 areas and any potential developments. We would collect the physical characteristics of the environment, importantly, foundationally water quality characteristics, hydrological variability, and hydrodynamic or hydraulic modeling so that we can represent the variability of flows in a habitat context. And then using life cycle ecology information and the importance of different parts of the flow regime from indicator species and additional biophysical relationships, we then look at establishing what we refer to these flow ecosystem and flow ecosystem service relationships. So that diagram I showed you in the beginning, where we're looking at these dynamic ecosystems, here we're trying to represent those dynamic ecosystems by looking at the relationship between the driver and the physical characteristics of the environment and its variability, and how the ecosystem responds to that variability, and whether the ecosystems can represent, or the ecosystem and indicators of that ecosystem can represent how abnormal changes of that environmental variability associated with anthropogenic developments or man's construction of dams, for example, could we generate those relationships? And if we do, we then can use those relationships to determine what is the requirements to maintain that ecosystem. So this is traditionally the approach that is taken to determine holistic environmental flow requirements using holistic methodologies. And the method we use is a tool called ProbFlow. But then we take that extra step by looking at probabilistic modeling or methods to determine the integrated synergistic effect of multiple stresses, because we find that in the real context, in a real world context, we're not only dealing with flow alone, but we could be dealing with barriers, with water quality issues, with alien invasive species, for example, and even just disturbance to wildlife impacts from people. And we want to ensure that if we consider the flows required to mitigate those measures, we can look at the requirements in a holistic context, and then that will give us the requirements we need. And we give that information, those requirements, back to the hydrologist, and the hydrologist will then turn it back into, I'll just show you quickly, into these statistics, which I showed you earlier. And if I present those statistics on a graph, you can see, you can get an indication of the reference flows available for an ecosystem, what the environmental flows would be to maintain the ecosystem in a B state, a C state, or a D state. So we would represent that level of sustainability as well. And we found that in our application, where we are working in areas where people haven't yet decided to allocate certain parts of the resource for development and other parts of the resource for protection, we'll just give them the alternative options to show that, you know, if this is the use, then you would end up in a moderately modified condition, or if this is the use that you allocate, you would end up moving towards that threshold of sustainability. And then this is just an example on the top here of the Bayesian networks that we use to do the probability modeling to determine the consequences of multiple stresses. And then here's the statistics that we provide, the outputs. And then in addition to the outputs with our probability modeling, we are able to provide stakeholders with this type of information. And this is really what's been very useful with our applications in Africa, is that it's important and useful to show users for supporting services, which includes the ecosystem, what would the basin and different parts of the basin have looked like using our probabilistic modeling tools under natural conditions, and this is what we expect to find. Then we can show them what we found today and what is the difference between the natural scenario and present day scenario. And we can actually go and test, and we've got evidence that can give us confidence behind this assessment to show that this is what we are seeing today based on the evidence we can collect in the field. And if that does hold water, then we can start to say, well, using those relationships, can we then propose how you could achieve a sustainable balance? So what would the implications of environmental flows be? And is this a sustainable balance between use and protection? And or if we don't manage present developments, and or we don't do anything about climate change, for example, where are we headed? So we're able then to present this information to stakeholders to show them what the consequences are of decisions and different decisions, and that there are opportunities for trade-offs between, for example, supporting services, for provisioning services, again, the 4 scenarios, for regulatory services, and then cultural services. And this is what we found has been very useful with the associated controls, the environmental flow requirements, and the statistics to allow users to make good decisions. So as a result of those 2 publications and the case studies we've had, we've just proposed these good e-flow practices, and they're available in the publications, but I'm just going to highlight that it's always important to ensure that you involve all stakeholders and that this vision between the use and protection of resources is established and that stakeholders agree. It's very hard to do that in some instances, but it's important. Benefits need to be shared by all stakeholders, what environmental flows are and what they provide us with, and that if you have the opportunity to determine trade-offs, then you must demonstrate the consequences of decisions. And importantly, present your uncertainty. Evidence behind their assessments are important. In environmental flow assessments, we need to carefully be able to demonstrate what can be attained and what cannot be attained. And then keep it as simple as possible. I'm almost done. Look at environmental flows and how it contributes to policies and who should be responsible, how can they be implemented, because there are often opportunities for us. Clearly identify what are the spatial temporal implications and look at applications of environmental flows. And we often try to align that with our existing policies and procedures in the region. So we go into different countries and find out how they could use the information and how we can best determine and present the information. Importantly, those flow ecosystem and flow ecosystem service relationships are crucial because that's the foundation of these assessments. And we find that even if the assessment is incorrect or we get new information later, what is vital is that evidence that we use to base our relationships on. Look at appropriate environmental flow determination methods associated with the problem at hand. Make sure that they're transparent and robust and address uncertainty, as I've said. Incorporate non-stationary processes in terms of like adaptability. I think that comes in later. And also just to present and engage it with different stakeholders. So we've been doing a lot of work in our area, and we've got some good case studies and we've had good experiences. And I hope that there is an opportunity or that if any of you are interested, you can look at some of the areas that we've adopted. I would even suggest speak to some of the stakeholders like the Nile Basin initiatives, our transboundary water resource management teams, some of the scientists in the area and look at some of the outputs to give you an idea of at least what we've learned. And also I hope that we have the opportunity to learn from applications in other parts of the world as well. So I'm sorry it was a little bit rushed, but I hope I've been able to give an idea of what we're doing in our area. Thank you very much.
That's great. Thank you very much, Gordon. Really interesting talk on environmental flows, which is a management strategy that will be of huge value across regions. We have a couple of questions for you that have come in. The first one says, you showed a map of heavily sampled or studied areas towards the northwest and the southeast regions. Is there any difficulty in advancing knowledge in other parts of Africa?
Definitely, you know, a lot of, so what we found is that you have minimum requirements of the data that you need, back to this map over here, of what you would need to undertake environmental flow determination studies. But you can go and determine that. And I mean, you can imagine that the importance of daily hydrological data versus say, monthly averages, the importance of long-term data sets. And in areas where you don't have the data, we still have the opportunity in an adaptive context to make precautionary decisions. You know, in some areas we have very little understanding of the biology and ecology of many species. We don't have indicator species, but with some information, and if we adopt the precautionary approach, we can do something and implement it carefully and learn from the consequences of our decisions. So definitely in some areas we have a lot more information than other areas. We have a lot more expertise in certain areas than other areas. And in some areas, the resulting confidence of environmental flow assessments are greater than others. But that doesn't mean that we can't do it. And it doesn't mean that we can't, you know, set up these requirements to certain areas and then carefully work towards ensuring that they are suitable. But everything needs to be adaptable. And even in some areas where we have tremendous amount of information, we're still realizing that we make mistakes and we need to learn from those mistakes.
Great, thanks. We have time for one more question. So we have one in the chat that says, how do you calculate or ensure that environmental peak flows for triggering essential biological processes such as fish reproduction are suitable?
So here's an example. I just showed you quickly. When you provide this information to stakeholders, you do give them an idea of what are the foundational base flows for droughts, critical low flows, the foundational base flows, including low flows and high flows, the amount of water required for floods. But if we provide this information in this flow duration context, you see here, what you have available to you here is an example of at what time of the year, how much water needs to be provided, and how does that amount of water change. And if you can look at some of these 1 percentiles up here, including the flood information, if you look over here, that we need a 2,000-year flood that must be provided every 3 to 5 years for a minimum of 7 days. We do incorporate those statistics into the outputs, and so that we do meet those requirements. If somebody then wants to go and unpack that information to find out exactly why that requirement is there, and or to look at the indicator species that we've used to determine those requirements, I think I gave this example here of the life cycles of a species. And we similarly use these cyprinids. They're such good indicators for us. Then you can get an idea of how much water is required and what we are allocating that water for. It's ecological cues, initiation of migrations and spawning behavior, for example. So that's a great question, because what we are trying to demonstrate here is that it's not just about volume. It's about when that water is provided, what is the duration of those releases. And in some cases, by the way, when you don't have dams to ensure that these releases are provided, it becomes quite difficult, but we have the opportunity to work with users who abstract flows and to work with them as to when not to abstract flows, and when events occur to allow those flows, freshets and flood flows in particular, to be released into the environment to then provide for those biological processes. And then we demonstrate to them that it works. And when we show them that it works and their action results in positive results or outcomes, we generally get good buy-in. So it works and it can be done.
Great, thanks. There's 1 or 2 more questions in the chat. So for timing reasons, we'll move on to our next speaker. But Gordon, if you have the opportunity to look through the chat and respond to any questions that we didn't get a chance to ask, that would be fantastic.
Thank you guys so much. And just to say goodbye, so it's a bit late here, so I'm not going to stay on for too long. But no, if you do need to get hold of me, please, I'll be available tomorrow. Thank you for the opportunity again, and bye-bye.
That's great. Thanks for attending. Okay, so our next speaker is Peng Ngor from Cambodia. Bun is the Dean of the Faculty of Fisheries at the Royal University of Agriculture in Cambodia, and has been involved in inland fisheries research in Cambodia and the Mekong more generally for over 20 years. So Bun, when you're ready, if you could start your presentation, that would be great.
Okay. Thank you. So today I'd like to talk to you all about the high fishing pressure of the Mekong migratory fishes in relation to flow variability. So these are my talk. First, I will review very quickly about the Mekong, and then talk with you on the studies, and then that I use for the studies. Then finally, I will try to illustrate the high fishing pressure or high fishing mortality of fish in relation to flow change at space and time in the Mekong. So to begin with, just show you quickly about the Mekong basins. The whole basin covers 5 countries from China, and then Laos, PDR, and Thailand, Myanmar, Laos, PDR, and Thailand, and Cambodia and Vietnam, 6 countries. And up here we call Upper Mekong Basin, and down here we call Lower Mekong Basin. So you see my work mainly apply for the Lower Mekong Basin. And quickly I will preview about the flow of the Mekong. The first this is the Mekong River that captured from the previous map, and the first 2 panel, upper panel representing the flow pattern, the inter-annual flow pattern, of the Mekong. One point in Cambodia and the others, three lower panel representing flow pattern from the major tributaries, the Sekong, Sesan, Sapok here. And probably this is the intra-annual flow variability for both the Mekong mainstream and the tributary. You can see there's clear pattern for wet and dry seasons. And similarly, these are the flow for the other tributary, one of the largest tributary and the largest wetland in Southeast Asia. And the flow almost identical from year to years. And this is the intra-annual flow patterns. We show clearly between wet and dry, and the peak flow mainly occur in October. And the uniqueness of the system, when the water level in the Mekong mainstream is higher than the Tonle Sap lake here, the river, Tonle Sap river, reverses its flow, which means flow from the Mekong back to the lake. And during the receding flow, then it distributes normal flows from the lake back to the Mekong. That create a huge flat power system and huge productivity, especially for fisheries. And quickly about fish diversity in the Mekong. The Mekong has some 1,000 species and highly diverse, not only for the richness but also for the size. Some fish are measured at 2 centimeters to the fish that measure at 300 centimeters. And it has some of the world's largest freshwater fish, such as Mekong catfish and giant barb. And for Cambodia, inland fish consists of composed of some 500 species. And here, the inland fishery produce some 500,000 tons annually, and 60% from the Lake Sap. Also, 60% of the catch are represented by migratory fishes. And here the protein intake from fish is very high, up to more than 80%, and GDP up to 18%. Quickly, so some management aspect for the inland fishery in Cambodia. We have closed seasons, especially during the rising water level, and open season mainly during the receding flows. And also the management also taking into consideration a large network of reserve, especially in the Lake Sap Lake, as well as the community fisheries, which is a form of co-management which has been established to co-manage the local fisheries from government and from the local people. So although we have huge inland fisheries here, many studies have already been indicated that our resources are overfished. Therefore, this study tried to identify what are the most vulnerable moments of high fishing mortality, especially in relation to flow, seasonal flow variation at various places. So to implement this study, I use historical fish monitoring data from three databases. The first one is the fish level drift monitoring. Second is the industrial scale fisheries in the Tonle Sap River, and the third one is the fisher catch monitoring, which take place not only in the Tonle Sap but also in the Mekong and other tributaries. And then we use the water level to build the hydrograph and see especially when and where there is high fishing mortality in relation to these flow patterns. So this graph, the blue line representing the hydrograph. So this is the and the red line representing the larvae abundance in the Mekong, one point in the Mekong, and data I present here every 3 years for visibility. So you can see the peak level abundance occur when the water start rising. And this almost identical, the pattern take place throughout the study periods. And similarly, this graph is showing the intra-annual variability of the level density drift, which mainly occur in between June and August and peak in July. And here is the historical data from the industrial scale fisheries operating in this area in Tonle Sap to target fish that migrate out of the Tonle Sap lake floodplains back to the Mekong. And you can see here the red line representing the catches, the landings from the fisheries, whereas the blue line is the flow pattern, and the peak catch mainly occur when during the receding floods. And the same data, but this is representing the intra-annual change. You can see this is for every 5 years. You can see the landing pattern look very similar, and the high fishing mortality take place mainly between December and February. And this is from other data set, which is we asked fishermen to record data at the Tonle River where the dye operated, where the industrial scale fishery operated, and this is 1 year round data, and it shows very similar pattern that the high fishing mortality really take place, especially when during the receding flows. And this similar graph from the previous one, but showing the intra-annual annual change of the catch, and the high fishing mortality really take place during this time of the year when the water is receding. And this move to upstream Mekong in Cambodia here. So the catch a little bit different from in Tonle Sap, where the high fishing mortality mainly take place during the low flow period. Seeing the clear pattern, you can see from the intra-annual change, where more catches seem to be occur during the low flow, especially when fish start moving down the Tonle Sap, and it takes some time to move up the system during the dry season for dry season refuge. And some also high fishing mortality take place when the water level start rising in early rainy seasons, mainly in May or June. And this is move a little bit more up the system in Cambodia in the Mekong, and the catch pattern, I will not repeat, is very similar to the one in KT. And then quickly similar visualization on the high fishing mortality. This is in the 3S system. I take one tributaries here, and the catch pattern, the high related to high fishing mortality, very similar to Tonle Sap, where high fishing mortality really occurs during the low flow periods, and also partly during the high flows. I think this is because when the fish move during the dry season, fish move out from the lower floodplains up the system, and then some might move into the tributaries, some stay in the mainstream for refuge. So this graph I try to relate to between it's a simple linear model between richness and abundance here in the Tonle Sap, and then also here up in the Mekong's mainstream. Similar model. This is for a tributary here in the SP. So generally whenever there's high abundance of fish being captured, also there are also high richness, meaning that more number of species are also being exploited or harvested. To summarize my point, here is the map representing Lower Mekong River system in Cambodia, and 3 main habitat at spatial scale, which include the lower floodplain here, the Tonle Sap Lake, as well as the lower system. And here is these 2 areas in the lower system are important area for fish rearing, whereas the upper system is very important area for dry season refuge and spawning, especially when there is increase in the water level in the Mekong in the rainy seasons. And this box representing the river, and the upper box is floodplain, and the hydrograph, and the time. And you can see here the high fishing mortality from the data presented in my presentation indicate that high fishing mortality will take place, especially when water start rising, where river fish start to move from river to floodplain for rearing. And also the other high fishing mortality take place especially when fish start moving from the floodplain here down here back to the main river channel for dry season refuge. And specifically in the Tonle Sap Lake here, the migration really take place in relation to the moon phase, especially about 1 week in the time we do, or around 1 week before the full moons. So in summary, key habitats are shown in the map. We have spawning ground for riverine fish, migratory fish in upper Mekong, in Cambodian Stung Trang and Kraceh, and feeding habitat down in the floodplains, especially in Tonle Sap, area south of Phnom Penh, as well as the Gerais. And the Tonle Sap river fishing mortality really occur in the early flooding period when fish move into the floodplain, and also extremely high fishing mortality occur in between December and Jan, or up to February. And in the Mekong River, the high fishing mortality occur in late May and early June, and during the low flow period. Whereas in the Gerais, high fishing mortality occur in late May, early June. This is due to upstream migrations, and again it takes place October, November, downstream migration to the main river channel. And during high fishing mortality, more number of species also harvested. I think this information are very essential for policy, also especially for reducing for policy intervention to reduce the high fishing mortality and conserve the migratory fishes in the Mekong. Thank you.
That's great. Thank you very much, Bun, for your presentation. The Mekong I always find a really fascinating river system. We have a couple of questions that have come in for you. The first one also relates to a talk we had yesterday from Anne Vivu from Vietnam, where you both talk about the large commercial fisheries on the Mekong. And the question is whether declines in catches are related to hydropower development, overfishing, climate change, or a combination of these, and how we can work out what the main cause of the decline might be.
I think that's very good questions, and it's hard to also give a precise answer. I think so far in the Mekong, many people, many researchers try to study the impact of of various environmental factors on on fish and fisheries, and people tend to refer to dams and climate change. Actually, there are many other factors, for example, land use change, also the other major cause. But up to now, I think there is no study that try to have a direct link between hydropower and fish. So it's hard to say, but I published one paper in scientific report using the industrial scale fishery. We already demonstrate that there is a sign of overfishing effect, where we find that there is strong decline, significant decline in the medium and large size fish, while some small size fish are still stable or even increase over time. I'm not sure I answer your questions.
No, I think it's yeah, it's always difficult to try and tease out the exact cause of decline, and there's definitely a tendency to try and study individual problems, and the interactive effects of multiple kind of stressors or threats is very difficult to understand. We have one final question for you. So early on in your talk, you showed some figures with the relationship between the egg larval richness and the hydrological peaks. And then later on, you did mention some information about migratory life stages. And the question is whether you have good data about when the fish migrations take place, and whether that data is collected using telemetry.
Yeah, before I continue to answer this question, I also wanted to go to the previous question. I think I think over the last 6-7 years, especially in the lower system, in the lower Mekong system, we also have a strong significant effect from drought. Several years in a row, I think that also has significant effect on fishery, not just only them. But clearly now the hot issues really people really point to the dam, especially I think more than 10 dams has been built, especially in the upper Mekong River in China, and then 2 mainstream dams already in operation in Laos, and several more are being proposed to build. So the main cost we can feel now from in relation to the flows is the dam and also the climate change, but we need more study to really tell or to really quantify how much from them and how much from the climate change. And also development in the floodplain, for example, in the Mekong Delta. I'm not sure Anne is here, but he might know very well that there's a strong, especially the rise intensifications and expansion in the Delta, which lead to cause significant effect on the land use change, flooded forest clearance, for example. I think also that also have very strong effect on fisheries. So back to the data for the larval fish, or all the data I presented here is mainly the long-term traditional fishery monitoring provided by the, actually it's done by the fishery agency here with the support from Mekong River Commissions, and we don't really have a telemetry data for this, but I think last few years we've been collecting fish independent data using the hydroacoustic in the Tonle Sap River, but it's not ready for use, and I think the team is still working to clean the data, and maybe they try to publish the data as well.
Okay, great. We have one question from the room. So Luis, did you want to ask your question?
Yes, thanks, Andrew. And just briefly, thanks for the presentation, Peng. You showed in your talk as well that there is a strong connection between the Mekong and the Tonle Sap Lake with the inflows and outflows, and how the strong dynamic inflows influence the activity or the filling of the lake and the emptying of the lake. So my question is, to what extent the discussion is going about the potential impacts of flow regulation due to the hydropower development upstream in the upper part of the Mekong and upstream of the Tonle Sap?
Yeah, I think that is very a good question as well. And I think so far, many development partners, also the government, they really raise strong concern on the reverse flow. I would like to show this map. That's the only map I have here. So actually, the Tonle Sap, the productivity of Tonle Sap depends very much on the Mekong. So we know clearly that if there is reduced flow, for example, even the dam on the 3S, Andrew showing you that we will have a case study on the Lower SHAASAN 2, which is block 2 mainstream here, or 2 tributary here also have a stronger effect on the reverse flow. And now we have several dam upstream here. Maybe I saw it a little bit with the map. Seeing this map is old, but at least it indicates, you see there are many dam has been built here. I think up to 11, including some of the largest, among the largest dam here in China. They hold a lot of waters, and now there is strong evidence that there is a significant increase in the dry season flows. However, the flow paths that trigger fish to migrate for spawning, for example, in the early flooding period, has been reduced and or moves out. That really have a strong concern to fisheries, especially the fish in the Tonle, that they have to move down the system to Tonle to utilize the floodplain in Tonle Sap. And also, it really now we feel that there is a strong lag in terms of the inflow to the Tonle Sap. The lag that has been estimated is up to 1 month. For example, we can see larvae drift in the normal year that I presented in this study usually come in July, but now because of the delay in flows and large volume of water has been retained up here. Then also the larvae drift also move like to July, and we haven't have I think with the delay in flow there might be some significant effect or there are some disruption on the reproductive success of fish, especially migratory species in the upper part of the Mekong River system in Cambodia, that also contribute to the decline of fisheries that somebody asked question previously. So yeah, a lot has been going on, and some organization like Stimson, they start to monitor dam upstream and how it's affect on the Tonle Sap, and also Eye on the Earth. I think this organization maybe from the US, they start also looking at flows and investigate the changes in Tonle Sap. A lot of debates ongoing.
Great, thank you very much. As with Gordon, I think there's 1 or 2 questions in the chat. So I realize it's quite early in the morning for you, but if you have the opportunity to look at those and answer those in the chat, then that would be great. If you're able to stop sharing your screen, then we'll move on to our next speaker. So our next speaker is Raquel, a freshwater fisheries biologist with 15 years experience working as an environmental analyst. Raquel will be given a bit more of an industry perspective as she works for CEMIG, one of the largest hydropower generators and distributors of electricity in Brazil. So Raquel, if you're able to share your screen, then please start when you're ready.
Great. Thank you very much for the invitation and the opportunity to present Peixe Vivo program. This year we are celebrating 15 years of existence, so it's really great. And it's a great opportunity for us to share and talk about our experience of partnership between industry and academy in favor of fish conservation. So CEMIG runs 67 hydropower plants, 6 wind power plants, and 18 solar farms. We are distributed by 26 Brazilian states, but our main work is in Minas Gerais state, where most of hydropower are located. The installed capacity are almost 6 gigawatts. So I think that yesterday was a great, we had great opportunity to see presentations and discuss impacts on fish, and hydropower is the main impact, right? And when we go back to the history of Peixe Vivo program, the biggest motivation for the creation of the program was fish death by hydropower operation. So here we can see fish, just to give an example, lots of fish in the tail race that can enter the draft tub when the turbine stops operating. So this is the main impact we can see here in Brazil, mainly in CEMIG's hydropower. And those fish inside the draft tub, they can be injured and be killed by the turbine when it starts up, and also being trapped if we need to dewater and to close the intake and dewater to do some maintenance here. So fish can be entrapped here, and unfortunately we can face some events with fish kill. So in 2007 we have a big fish mortality in Três Marias Dam that really caught attention from population and fishermen and environmental agencies. We have tons of fish died inside the turbine, and environmental agencies applied expensive fines to the company. This is just an example of one of it. We had more than 10 million reais, it's about $2 million of fines that we needed to pay that time because of the fish mortality. And we have, and this kind of event with tons of fish have major consequences, right? Besides the ecological impacts, we also have conflicts with local communities, loss of confidence with environmental agencies, fines, and image problems with stakeholders. So that's why in 2007, CEMIG created Peixe Vivo program with the mission to minimize the impact on fish, searching solutions and management technologies that integrate the electricity generation by CEMIG to the conservation of native fish species, promoting community involvement. And we have 4 principles. That is, adopt scientific criteria for decision-making, modify practice according to the information generated, and encourage the dissemination of program information to society and work in partnership with other institutions. So we believe that environmental issue it's not a guesswork. We really need to develop study to understand better the interaction of fish with the environment and the relation with hydropowers. And we have great challenges here because, as was said in other presentations, Brazil, we have high freshwater fish diversity, and considering the diversity of watershed and watershed specificities, different water quality characteristics. We also have a high diversity of seaweed structure, depending on the plant. Fish will interact on different ways. We also have policy and regulatory framework to deal with and to discuss financial costs of fine versus costs of solutions. So companies need to understand the dynamics between those aspects and develop strategies tailored to address challenges at the local ecosystem level. And how to do that? Well, at least we are trying. And we have in Peixe Vivo program, we work with 3 pillars. That is our base. That's the main base for our work. Okay, so we have research and development, we have monitoring, management, and conservation programs, and also involvement with the community. And to do that, we establish partnership with the academy, within the company. That was really, really important to engage with engineering area, to legal area, planning, and also we establish partnership with society. So here, just to give an idea of the different institutions that we established partnership over those 15 years. We have 23 research projects financed by now. 5 of them are in process, but we have more than 10 projects also with different aspects, with social aspects, with management, and also some supported projects. So I just going to briefly summarize the benefits of those partnerships and in relation to the projects to give an overview of the program. So I try to categorize the projects on main themes, because it's a lot to if I was going to talk about each project, it would be too much. So I think that I can when we talk about the fish behavior and migration patterns is assessed by some projects. We had some procedure changes with the results we received. Like we changed hydropower operation because considering the period of more abundance of fish in the tail race, for example. We also did some survey changes regarding periodic and previous monitoring to risky operational procedures. We also did some projects to access migratory routes for determining the need for fish passage facility. Professor Paulo showed some results yesterday. We also had some projects for fish stock program assessment. And this is really important because we had some changes in procedures regarding fish stocking. The projects concerned the projects raised some concern about the effectiveness of stock and conceptual change on the issues of release of unmarked fish. Also reviews of genetic variation of wild fish versus hatchery fish. We also had some assessment of DNA barcoding to facilitate species identification for breeding, and also change in technical specifications for contracting services, and even discussion with environmental agencies regarding fish stock efficiency. And in this last case, after some years of discussion with the results that we got from those projects, we now do not perform any fish stock in our reservoirs. And also some environmental agencies are not even giving permits to fish release. And I think this will be discussed tomorrow, right? Ecological condition assessment of hydropower basins was also a big theme from some projects we had. And the projects that did this kind of assessment helped us with to subsidize programs considering deployment of riparian areas, water quality assessment, erosion control, and also change in methodology for sampling eggs and larvae. And we are getting better with this. Probably going to change something of the sampling, considering a project that's already in process. We also had a project that evaluated the effectiveness of fish monitoring programs and established 10 guidelines to improve monitoring in general for the company. And that was really helpful. We also developed a database for fish data from research projects and monitoring. The system we'll call Symposium. And I think that it will be really helpful for us to improve fish monitoring and subsidize better management actions, so we can have new questions being asked and use the data to try to answer that and see other perspectives from the hydropower reservoirs. Considering the project, we also have great results with fish kill reduction. We developed a risk assessment of fish death that was developed in 5 steps. Considering the time, I'm not will be able to give many details, but we did a historical data on fish death at CEMIG's hydropower. We did a classification of each hydropower according to its potential of fish death. Here you can see this is Minas Gerais state, where the main hydropowers are based, and the colors indicate the risk. The red one is the high risk. We also implemented a specific instruction to systematic planning of operational procedures, considering engineering, environmental, and biological aspects in order to prevent fish death. This is really important for us. It's like the real guide to control the risks during operation. We also established a standardized fish monitoring by fish biologists prior to the execution of operation procedures, risk to fish, and create an strategic indicator named affected biomass that considers fish dead biomass. So we can monitor and be audit of compliance performance. Considering also fish kill reduction, there was a development of fish screens that was deployed at Três Marias Dam. Here we can see the effectiveness of the fish screens to reduce fish death during turbine startups. Without fish screens, we have some of the startups with fish kill events. And after the deployment of the fish screens, we reduced a lot fish kill during startup. And after they being automatic, it's been 4 years now. We had, it's more than 4 years, sorry. I think it's about 6 years. We have no fish kill at all. Here we develop a fish risk predictive model that's really our that really helps us before the performance of operational procedure that's risky for fish. We try to correlate fish abundance downstream the dam with fish abundance that was rescued inside the draft tub. So after that, we developed these models for the hydropower that present more risk for fish death, and we have a base to compare. So when we have operational procedure risk that's risky and is programmed to happen, our biologists go to the field and do the the monitoring downstream dam, and considering the result, we can say that okay, it's we have low risk now, we can go on with the operation procedure, or no, we have a very high risk now, we need to reschedule the operational procedure for another time that's more favorable, and this really happens. So it's really important, this monitoring. They also perform monitoring our team inside the hydropower during the watering, for example, when you need to rescue fish here, as you can see in this photo. So we perform water quality monitoring, help with the rescue, do the assessment of the fish that's being rescued, and the release in the river. So just comparing before and after Peixe Vivo program, we have registered a reduction of 77% of fish biomass that's dead in operation. We also observed a great reduction on the fines, an amount of 98% of reduction. And here, just some more numbers considering technical scientific production. We had just update this number. We have more than 619 publications. Consider all that 23 projects that I mentioned. Here I highlight some books that we produce, Peixe Vivo series. It's free that you can download in CEMIG's website. Probably not available now because of electoral period. So after November, probably will be there again. But it's free for download. Most of them are in Portuguese, but we have 2 volumes in English. And the idea of these books is to bring the results of the projects in a more accessible language. And also I highlight here the papers published in an assessment we did in Google Scholar on February. We saw that we have more than 2,500, almost 2,500 citations with an H index of 27. So I think this is really interesting considering the knowledge that is being produced with the help of the projects we finance. And here, another great result that I think that's people involved in our projects, because we need them. Really need people to help us to think about the problems and think about the solutions. And also, I highlight here formation of professionals, helping with scholarship to master's degree, PhD, and undergraduate researchers also doing monographs. So this is really important for us to have more people being formatted and helping with to help with fish solutions, considering all impacts we have. Here is our staff that I really want to thank, all the help and effort during these years, because of the results are also the results we have, and I presented here from partnership, but also with with these guys here. Thank you. That's it. Thank you, guys.
Thank you very much, Raquel, for your really interesting talk. We have time for a couple of quick questions. I'm just going to scroll through the chat. The first question is, what are the benefits for CEMIG of having this Peixe Vivo program?
Well, I think all the last of my slides are the benefits that we have. We changed lots of things considering operational procedures. We could reduce fish mortality doing these procedures. We also, I think we have better monitoring programs, do this investment in projects that help us a lot to get better techniques, to improve methods. I think, I think we have lots of benefits regarding reductions of fines, because this is also not good. I think I forgot I was. I think that over the time we also gain lots of. It's not the word. I'm not going to. Confiança. I forgot the word in English, but the credibility. Okay, the credibility really helped us also, because adopting those principles that I mentioned in work with transparency, I think the credibility with environmental agencies, with academy, with partners improved a lot. And this is really good, because we are just really facing the problem. We're not trying to cover anything. And I think that when we recognize this, we really can find some solutions and resolve some problems.
We have two questions that are both related to e-flows. So I thought I would ask you that question, and that is whether you have any experience with simulating e-flows at these hydropower facilities.
No, we don't, unfortunately. But we have a project in progress that's trying to do a kind of these tests. It's also in Três Marias, the power plant that I showed. We are trying to study how Três Marias can or could contribute to the flow, to increase the flow, sometimes maybe doing some opening the spillway to help with fish reproduction in marginal lagoons downstream. So we have a project that's in progress that's trying to do this assessment, how Três Marias can increment the flow downstream together with the tributaries to help with fish reproduction downstream.
We have a question from the room from Andre. So would you like to ask your question?
Can you hear me? Yeah, thank
Yes.
you, Raquel. Good to see you. Raquel, you mentioned that CEMIG is the Peixe Vivo project is starting 30 this year, right? And
yes.
Since CEMIG is a state company, I wanted to ask you, how good is CEMIG looking, or the Peixe Vivo project is looking at these 30s? It's better than was in the past, it's holding. And the reason why I'm asking you is that we are facing major cuts in funding for research in Brazil. And I would love to hear from you guys how much that has been also progressing to Peixe Vivo, the reduction in funding for research, and how much of that money that CEMIG now uses for research are from the state or actually from the company, since we have this public-private kind of situation that's been going on. But thank you very much for your talk.
Andre, I think, well, 15 years is a lot, I think, for us to have a a program like Peixe Vivo, right? I think it's not common, and we have ups and downs over those years. I think we're entering in a down, unfortunately, considering investments. Some of our projects are ending by the end of this year. They are finishing by the end of this year, and I'm not seeing great perspectives for new ones, unfortunately. I always think, I try to think positive and try to find new solutions to do some projects. But well, we have research and development project by ANEEL. Most of the projects that we have nowadays are from this kind of resource of finance. At the beginning of Peixe Vivo program, we had a greater, was the time of, we had the greatest investment from CEMIG own resources. But nowadays we use R&D resource from ANEEL, and the things are changing inside, and I'm not sure if we will be able to have more projects for the next years. I'm really concerned about that. I'm trying to discuss with this with my superiors to find solutions, but we are not in good times for project, as everybody.
That's great. Thank you very much, Raquel. There's still a few questions in the chat, so if you have time to look over and answer those, then that would be great. So our next speakers are Andreas Galeano and Luis Garcia-Melo from EPM here in Colombia. So EPM is a public utility company and is responsible for developing and distributing much of Colombia's hydroelectric power. Andreas has expertise in population and community ecology and management of natural resources, but with a particular focus on water resources and hydrobiological communities. And Luis Garcia has an MSc in biological sciences and 20 years experience in fisheries management around dams in Colombia. So if you're able to share your screen and then start presenting, that would be great.
Good afternoon, everybody. I'll start sharing my screen. Very well. Thank you so much. As I was saying before, EPM is a public utility company, a Colombian public utility company. It is located in Medellin, which is the capital city of Antioquia. Now we have other affiliate companies across South America. We have 7 business lines, which include the power generation, power transmission, power distribution. And this is a company that benefits over 25 million people across Latin America. In terms of hydroelectric power, today we are the second generator. The capacity is 3,800 megawatts. We have a project which is Ituango, and we will have 1,400 additional megawatts. We have 36 hydroelectric power plants, 3 thermal power plants, wind park, and we also have some solar self-generation systems. And this is also the company that has the highest number of micro power stations in Colombia. This is the Water Resource and Biodiversity Integrated Management Policy. We are meeting the SDGs, and we also have other national policies that deal with water resources, and the idea is to frame this as a company through a certain set of actions that involve natural resources such as flora, fauna, and soil, with some long-term and an integrated vision, sustainable territorial development, the management unit that includes basin projects, and there should be a common agenda in the territories. And we also bet on the governance of the territories where we have presence. This policy basically involves a series of initiatives that are related to regional planning, water resources, biodiversity and ecosystem conservation. And we also tend to involve our providers and vendors. We also deal with the risk management, which is highly related to water resources and biodiversity. And finally, the water monitoring and biodiversity indicators. And as I was saying before, these principles are highly linked to a long-term vision in the regions, a sustainable management in the territories where we are present, and governance. If we move to the fish topic, we are focusing on the department or the state of Antioquia. And we have the Cauca River, which is the largest tributary of the Magdalena River. And we have a series of projects that work with this river, with the Cauca River. We have some projects that are close to the metropolitan area, the green area here that you see here. And we also have another tributary, which is the Neshi River. So we start the journey here in the upstream, above 2,000 meters, at 2,000 meters above sea level. And we will complete this with the Tuango project. The basin has almost 64,000 square kilometers. There is another leg that is not in the Antioquia department, and we are not there. Today, reservoirs are some sort of ultrasound of what's happening about what's happening in this area. So today, we have to deal with several changes and impacts derived from what's going on in the upper stream of the dams. We also have to deal with solid waste pollution that arrive at the dams, water quality, and there is also a sedimentation issue that is related to what's happening in upstream. So we have several impacts that are affecting the reservoir, and we also have to deal with them because they will be interacting with other impacts derived from the construction of the projects. And this is a condition that is linked to the impacts that are happening. So this basin focus is very important for the integrated policy, management policy. EPM has been working with University of Antioquia through certain agreements to manage the information that we are collecting in the field. So that information can allow us to improve decision making. So through a contract that was conducted between 2017 and 2020, we were able to identify a series of issues, and we were able to conduct some studies. And this is very similar to what we heard from the PES Vivo program. This is the publication of another book, and this allowed the funding of a book that can be considered a milestone about the Magdalena River Basin. This is what happened. We are also talking here about what's happening in the reservoirs, and we include the pollution of the systems. This touches a conservation issue, and it is also related to the presence of parasites in the fish that live here in this reservoir. And this will allow us to train 5 master degree students. We also have some research groups. Initially, we were working with the Ichthyology group from Universidad de Antioquia. Now we also have students from other disciplines or other programs. As for the reservoirs that we have at 2,000 meters above sea level, we have Piedras Blancas, which provides water to the city of Medellin. We gathered information based on a fish kill that we had there, and it has allowed us to find that assemblages here are dominated by exotic species that were introduced in the Department of Antioquia several years ago. So we find Siphophorus maculatus, and we also have Hemibrion sp, which is probably the dominating species here. We also have the Guadalupe hydroelectric complex. This is an older project. We see kind of the same situation that I told you before. And we have 2 reservoirs where we have some fish species that have been introduced a long time ago. We have trout and carps, and despite this, we also have some species that have resisted the impacts of the construction derived from the construction of dams. And there is another one, which is the Rio Grande hydroelectric complex, where we already started some monitoring studies to determine the behavior of these assemblages. So maybe there were some initial impacts, and today it is very difficult to establish if these impacts were caused by the introduction of these species or due to the fragmentation of the habitat derived from the construction of the dams. And additionally, what are the impacts that are being derived due to the dams? We also see that there have been fish kills linked to some drainage of wastewater. The Porce River, where we have these most recent hydropower projects. Here we see the classic indicators or ecologic indicators of diversity and abundance. The response has been kept around the same levels, and they take us to ask ourselves that today environmental authorities are demanding some indices, but they are not very good, and they do not tell us what's happening with the fish fauna there. So the project that we have here, Porce 2, was the first licensed project in that 2001. Before that, these hydropower projects did not have any, they did not have to comply with fish measures. And there's also an increase in terms of the knowledge regarding the fish. For Porce Porsi 3, we have another baseline. As long as we move on with the construction, there's been an improvement in the monitoring of the fish that were impacted by the projects and the follow-up that we have been conducting. For Porsi 3, we also have we also monitor some food groups, and we see how the composition of those groups changes, and the number of species that were insectivore started to decline, and the composition changes. With the University of Antioquia, we've been conducting some downstream studies related to migrations. We found that even though the site has the presence of some migratory species, the site does not have the same importance of other downstream sites, such as the Nechir River, because they show a higher complexity. We've also been conducting studies, or the first pilot studies, related to eDNA. And there was a kid that was talking about eDNA. And these systems would allow to reduce the pressure and the impacts of these projects. In terms of management strategies, we've also conducted some studies about stocking. We conducted studies related to conservation, genetic studies, about if we were having bottlenecks with these species. We also conducted some niche studies to determine what are the most suitable conditions so this type of fish can develop. We also have fish inspection and rescue related to sudden changes in the flow. These are some of the results that we've had for 10 years. And we have rescued over 10,000 individuals. And finally, fisheries management. Good afternoon. Very quickly, I want to talk to you about the Ituango hydroelectric project and the fish resources. But I want to mention that this is a project we all know about due to an event that happened in 2018 due to a contingency where there was a premature gathering of the water in some unstable areas, and this caused the formation of the dam, and they produced some impacts downstream. So this is the largest project that EPM has. The area of influence is includes 12 municipalities. It is located in the northwestern part of Medellin. The capacity is around 2,400 megawatts, over 13,000 gigawatts on an annual average energy. The turbines are, we have 8 turbines. The average flow is 1,000 cubic meters per second. Here in this area, the Cauca River becomes narrower because we are using energy from that area, the area of the canyon. The reservoir has volume of around 20 million square cubic meters. The length is 78 kilometers, and here is where the impacts linked to changes in habitat are more evident. This project will start operation in the second semester, so maybe by October the first unit will go in operation, and based on the contingency, the project has a management strategy that is related or that ensures the protection of fish resources. And this includes 11 management actions. And due to time constraints, they are related to knowledge, mitigation, and restoration. Very quickly, I want to mention that the project has been conducting studies regarding composition and structure. Very briefly, the composition or the higher areas have a lower number of species. When we go downstream, we start to see other type of ecosystem, and the abundance increases, and also fisheries increase. So we have around 162 species that represent almost 70% of the fish fauna of the Magdalena River. This is important because this used to be a Cauca region that had social unrest, that it was neglected by the government. And with the contingency, we were able to see it. And we were able to deal with management, with environmental management issues related to fish. We were able to determine the migration routes in this Congress, along with the University of Cordoba. We have important data about the areas for spawning and what is the impact that is linked to this migratory fish species. We know that there are some species that are being highly affected by the barriers, such as Boca Chico. These are species that are affected by the dam, and there are others that are not affected, but for instance, the striped catfish. Based on this, we also conduct studies about fishing or fisheries analysis, and we've been able to provide visibility to this, and we've been able to see or identify the fishing characteristics, because Colombia did not have relevant data on the fish stock in this area, because this is an area, even though it is like the focus of the project, there are other impacts that are derived from mining activity. Regarding mitigation, we know that these projects have problems that are linked to the arrival of fish to turbines on discharges. So we have a conceptual design and the university was one of the partners, because, and unlike other basins, the dynamic that is linked to the flow regimes and the altitude of the dam did not allow us to use other characteristics or actions that are undertaken in other countries. So we need to see what is the impact of the project for the future fish that will get here. This is a work that has been conducted jointly with the community. When we have events in the area, we have even documented something that perhaps hadn't been shown in other dams, the presence of fish that get entangled with the macrophytes. And we have also dealt with this, and we have provided a response to this kind of contingency. And finally, regarding restoration, along with the National Fisheries Authority, which is the one that regulates fisheries in Colombia, there has been an important resolution that was issued, which is one of the first ones to regulate fisheries and the special management zone downstream where fish would arrive eventually. And along with fishermen, the idea is to deal with these fish resources. We also have technological packages that we have developed for species that did not have this development. And potentially they can be used in different stocking plants in the future. And finally, since ecosystems in August are very important to spawning, we have implemented some compensation actions in these ecosystems. And they are based on cleansing these channels that connect rivers with swamps.
All right, let me finish with this slide. We discusses a associated project, how we've worked with the academia so that the authority is way more, it has stronger requirements. So we need migration studies, endemic, endangered, and restricted species, studies related to reproduction areas and migration routes for rheophilic fishes, to establish cumulative disturbance condition, longitudinal and lateral fragmentation, water quality, sediments, biotic integrity index. So we have a lot more requirements in terms of knowledge so that we can decrease those impacts related to the building of dams and different man-made structures. Thank you very much for paying attention to this talk.
Muchas gracias por la presentación, muy bien.
Thank you very much for your presentation, very detailed. This is one more example of how utility government companies can manage dams. I saw that in your final presentation, you recommended some actions in terms of environmental impact, and there are several of them. So apparently, initially, you were asked about some classic indices and ecological indices as well. And now you talked about some topics related to fisheries and so on. Amongst those, are there any that you'd like to mention and why? Or are there any that are not detailed there that you also consider important in terms of fisheries and fish? Today, at the university, we've established certain indicators, such as biotic indicators, to establish those functional changes to see how they've been changing depending on the spot you analyze. One to analyze upstream, another for downstream, reservoirs, streams, and so on. And what we saw that was that even though in the academy we've been focused on reviewing indices, now the authority has requirements in terms of these indices that we've been seeing for years. The academy is ahead of the government in terms of this. So today we are exploring how we can improve our understanding of these impacts, for instance, in terms of parasites. This is very interesting because we hadn't analyzed what happens how the parasitic load, when it increases, it relates to changes in the environmental systems.
Bueno, muchas gracias. Thank you.
Okay.
Well, now we continue with our presentations. Our next speaker is Oscar Ling. Oscar is a professor of civil engineering from the University of Concepción, Chile. He is the head of the Hydraulic Engineering Research Group in Chile, which studies, among other things, interactions between fish and the hydraulic environment, and applying this research to help solving fish passage and hydropower related issues. So thanks to Oscar for coming here, and now the floor is yours.
Okay, thank you, Hector, for the presentation, and Ruth for all the organization. I'm very happy to be here and see you in person after so long time with pandemic. I will present a brief introduction to the considerations of fish swimming abilities in fishway design. For that, I divided the presentation into three parts. The first is a brief introduction on fishway design. Then I will move to fish swimming abilities. And finally, I will present some design criteria for a study case. So first, when we think on a fishway, we need to consider the biological, ecological aspects in order to select the best suited fishway type, which is defined then by the substrate, the geometry like length and slope, but also hydraulic parameters like discharge, flow depth, and velocity, and importantly also the turbulence, because we are talking about altered flows, like, for example, those in the pictures on the right. So there we see some technical fishways and also a more nature-like in the center part. In all these cases, we have altered flow in the sense that we put some obstacles into the water, and due to that, the water develops turbulence with different vortices that will somehow interact with the fish swimming and affect their performance also by passing. So turbulence effects on the swimming capacities of fishes have been studied, of course, and important parameters are the turbulence intensity, which is a measure of the energy, the fluctuation of the velocity. Also, periodicity is important, is usually expressed through the Strual number, but mainly the point here is that periodicity allows some fishes, in some cases, to predict a little bit the current when the vortices are periodically forming. And the size is also important in relation to the fish body length, because sometimes when the vortices are large enough can destabilize fish swimming. In other cases, when they are small, like in the upper picture there, they can even motivate fish to swim in a certain direction. So when we put obstacles, we think we are providing more flow diversity, and this will promote the fish passage through a fishway. But it is important to put a lot of attention on the flow velocity fields and the turbulent kinetic energy that is developed, especially in these obstacles fields, in order to ensure that fish will be stimulated in the way we need it. For that, we have also an important tool in hydraulic engineering, which is the physical modeling. Here we see a physical model of a real situation. In the pictures at the bottom, you see in the left the physical model, and to the right the real situation. And it's important to test these configurations, in this case for a fishway in a steep ramp, for low discharges, avoiding sedimentation, for normal operation conditions, but also for very high discharges, extraordinary discharges that could damage the fishways that are built, especially when we are using boulders and other stuff that is just placed on the riverbed. The situation is well solved, especially for salmonids. Here we see a fish ladder working, where salmon jump up the ladder easily, and this is a standard solution implemented in many hydropower plants in the northern hemisphere. But the challenge became more difficult when we think on multi-specific fishways, and especially when we want them suitable for small-bodied fish. So how to face the problem? One of the important things is to take into account the behavior in fishways. And it is a mixture, of course, of motivation, attraction flow, and swimming abilities to pass the fishway. And basically, I'm looking for a device like this here, where the young Martina is motivated to pass many times during the day, up and down, like in a fishway, a given target fish species. So this, we have high diversity in swimming styles, fish that burrow, are jumping, able to fly, etc. So it's very important to be specific enough. And in my study case, I will face the case of the Chilean species. They are mainly small-bodied species, like those in the pictures here. And the three main properties that will characterize the swimming abilities are the swimming mode, the endurance and critical velocity, and also the behavior in these altered flows due to turbulence effects. So the next part will be subdivided also in these three swimming aspects. So for the first, the swimming modes, we adopted the Breeders' classification, just to have a first screening of our species, and we classified them in these different anguilliform, subcaranchiform, caranchiform, and so on, which basically distinguish the part of the body, the portion of the body that is moved for propulsion. And we have basically three classes for the 46 Chilean species. And of those, we selected one representative of each one, the Trichomicteros aerolatus in the top for the anguilliforms, the Cheirodon galusde for the subcaranchiform in the center, and at the bottom, the Basilictis microlepidotus for caranchiforms. And we then took a closer look on the critical velocities and endurance. But here we see the first one, the Trichomicteros, the swimming tunnel exhibited a very erratic behavior. The motivation to swim is not clear. Sometimes they do sprints, but the rheotactical expected behavior wasn't there. So we developed some measurements about the velocity and the amount of sprints per time unit in order to characterize the behavior of Trichomicteros. Differently, in the case of the Cheirodon galusde, here we see in the swimming tunnel for different velocities, low velocities on the top 7 and 7.6 centimeters per second, and it wasn't motivated to swim, but if we increase it a little bit to 10.8 centimeters per second, it started to make some sprints. And for higher velocities, here 34 centimeters per second, we see a rheotactic behavior, and the fish start to sustain the flow velocity. The best individual cooperating with the fish tunnel was the Basilictis. This was a rheotactic behavior, and we observed always for the different velocities this kind of swimming style. So it was more the standard expected behavior. So we could in a way the behavior of and the resistance, the endurance of Basilictis and also Cheirodon galusde, and we developed some curves for endurance, identifying the sustained mode, the prolonged mode, and bursting, and the critical velocities for all these cases. And using that, we developed some curves to deduce the maximum fishway length that would allow the passage of individuals from this species. Next to that, we were interested in the effects of turbulence, so we put it a standard or a very well-known obstacle, which is a cylinder in a channel flow. In the wake of cylinders, there develops a well-formed alternating wake with vortices of a given periodicity. So we observed then what was the behavior of this species in the wake of the cylinder. And for the Cheirodon galusde, we observed a tendency to adopt a burst and coast-like swimming mode in the free flow, but in the case of the cylinder, we observed a lot of drifting events, destabilization, and these individuals were not comfortable with the obstacle situation. In case of Basilictis, surprisingly, it adopted in the wake of the cylinder a Karman gating-like swimming mode, which is very favorable to promote the fishway passage. It can guide a little bit because in this case, the fish extract energy from the vortices of the current. And so we went on the problem of a multi-specific fishway. Of course, this is complex and it deals with a lot of details, as we have seen in the previous presentations, like how many target species do we have, if there is or not basic information on the species available about the swimming styles and so on, and also the feasibility to build a given fishway in a situation. I think for very high dams, this is not really the best solution. In our case, we made an analysis and determined that for central Chile, balancing a little bit the species present and the hydropower plant that are planned in the different basins, mitigation is not required in 15% of the cases, and is required and also feasible in only 35% of the cases. And for that, we started to develop a kind of prototype, testing different configurations of baffles, as you see in the panel at the left. And here you see that finally it was successful to allow the passage of the Trichomicterus and also the other species. This is a flow field characterized by cross waves and flow separation in between these baffles. So combining the basic information from the swimming abilities, we were able to develop this prototype that serves as a multi-specific fishway for some different species. So final little messages: fishway could help mitigating fragmentation, especially for low heat dams. Multi-specific fishways, including a big number of species and small body species, are more challenging. Swimming style can help fish passage, and of course complementary approaches combining field and laboratory studies are recommended. Thank you for your attention. I'm open for questions.
Thanks to Oscar for his very interesting. You show us different aspects of us biologists use it to see fishes. So now we got a nice example of how our fishes can be studied also in other fields. Now we got 5 minutes for questions. So anyone here from the room might have one question, please. I got a question here in the chat. It says, is there an optimal stairs longitude for these fish movements?
Especially see in some needs, I think stairs are especially designed for that species, but in general, the fishway length is related to fish endurance. So it will depend a little bit on the flow velocity flowing in the fishway. The distance that could be covered by the fishes in the fishway is dependent on the flow velocity in the fishway. So it's not that direct that you can say there is a maximum length of the stairway for a given species. It depends on the discharge that you are putting in the fishway, basically. Mm-hmm.
Thank you, Oscar. We got 2 questions here. One is from Luis. Please, Luis, you can put your camera and microphone. Thank you.
Thank you, Oscar, for this very interesting presentation. I'm curious about the results that you showed about the behavior of fish in turbulence, putting the cylinder and then showing the common gait, swimming. And the swimming behavior of fish in turbulence is quite difficult to tease out, because turbulence is also a phenomenon that occurs in 3 dimensions. And I'm just wondering if you can just elaborate a bit more on whether you've got 3D dimension measurements of the turbulent field in the flow, or in the flow field where the fish was navigating, and how that could be correlated with fish behavior.
Yes, turbulence is a very complex topic, of course. Basically, when you put an obstacle of a defined geometry, you expect also that vortices have a defined geometry and a more or less periodic behavior. So it can be three-dimensional. For instance, when you have some pipes or axes that are transferred to the main direction of the flow, you can produce also vortices with different orientations. And they have different effects on fish, especially vortices that are rotating with a horizontal axis are more destabilizing than vortices that rotate with a vertical axis. But in this special case of these wake vortices, it has been documented, especially for trout, that they are able to migrate upstream, covering very high altitude differences only because they extract energy from the vortices. So only by feeding, the energy wouldn't be available to reach that high altitudes.
Thank you, Luis. We got time for one question more. So the next question is from Andre Castro. Please, can you do it?
Sure. Thank you, Oscar, for your presentation. I was curious about when you said that the fish has to be interested in going through fishway, it has to be challenged in a way. So do you think that using different designs along the fishway could also improve the interest of fish keep swimming, you know?
I think so. Of course, I can't guarantee that, and it has to be studied for each case specifically, but you observe this pattern that there are some flow elements that are attractive for different fishes. And for instance, in the case of this Trichomicterus that I showed in the last video, we made a lot of tests, and for many situations they are not interested in the passage, or they are destabilizing and not able to cross a given wave and so on. So yeah, it's a matter of the configuration, I think, to achieve the goals of fish passage.
Thanks again to Oscar for your presentation.
Thank you very much.
We got another question, so please, if you can do it, you can do it in the chat.
Yeah.
So now we move to our next participant. We now have the presentation of Luis Silva. Luis Silva is a senior scientist in the Stoker Lab based out in the ETH-Zurich. He is in the process of establishing ecohydraulics research there in Switzerland, which will focus on studying fish and hydropower related issues, and in that country, in Europe, and also around the world. He has a particular interest in issues in Brazil, having studied and held academic positions there. So he was previously working in the Federal University of San Jose del Rey. So now, Luis, the floor is yours. Thank you.
Thank you, Hector. And firstly, I would like to thank the SHAASAN network and all the organizers of this workshop for the opportunity to be here and present and discuss a little bit about migratory fish and hydropower and the aim of my talk. So I'm currently based in Switzerland at ETH-Zurich, which is the Swiss Federal Institute of Technology. It's a university in Zurich, and I had previous experience. I'm originally from Brazil, so I had previous experience working with new tropical ichthyology. And then I had a 4-year placement in Australia as well, where I did work with subtemperate species over there in a different condition, dealing with lots of irrigation issues. And now I'm in Switzerland and moved to the country back working on hydropower issues, which is a key problem for the country to solve. So the government has put in place a lot of actions to help mitigate the effects of hydropower on fish. And based on this experience across 3 different continents, I can say ahead of time that our issues are quite similar. Problems are always very similar in different ways, dealing with different species, but we do move towards trying to find similar solutions as well. And that's what I want to bring to this talk here a little bit, but focusing on migratory fish, which is the topic that I was asked to talk about. So talking about migratory fish, I will, in this presentation, go through some aspects of conservation status of migratory freshwater fish, threats and management pitfalls. And later in the presentation, you will see what I want to mean with management pitfalls. So I'm going to start with this typical graph and illustration that talks about and deal with the diversity of migratory fish. So the last estimate we had account for over 1,100 migratory species worldwide. And if you look at the new tropical system, where we have the highest diversity of fish across the globe, we are dealing with several hundreds of migratory fish species as well, mostly from 2 specific groups, which are the siluriforms and carassiforms groups of species. And they present a very complex set of life histories with, I'm not going through these different graphs. This is here clearly just to show the complexity of the different migratory behavior, where, for instance, in this graph, the conceptual model here in the middle, or this one here on the left for the Paraná River, for the San Francisco River, you see adults and juveniles moving upstream, eggs and larvae moving downstream in the system, and we do require those movements. And it's really important that now here we understand that we are talking about adults, juveniles, eggs and larvae moving, because quite often when we talk about migratory fish, we tend to focus on adults only. And I want to point this out later in this presentation as well. But also very importantly, in some systems in the neotropics, we also have these lateral movements, as in the Paraguay River Basin, for example, which are quite important to connect floodplains to the main stem of the rivers. And this is also quite often a type of movement that is neglected when we talk about barriers and impoundments, limiting the lateral movement at different locations. And obviously, for all of these different fish species, there is severe threats for those species. And as part of freshwater group, it is under severe decline, as freshwater vertebrates are now at a rate of decline that's much higher than terrestrial vertebrates. And this is quite alarming, and we should look into this as well. So the last estimate, considering data from 1917 to 2012, showed 81% decline in freshwater biodiversity. And looking into fish, 30% of the diversity of fish, or at least 10,300 fish that were assessed by IUCN for conservation status, about 30% of them are at a certain level of threat or risk of extinction. So based on that, I had the opportunity to join a group that includes Stephanie Dannett from the Zoological Society of London, to develop this index, the Living Planet Index for migratory freshwater fish, and look at the conservation status of different populations of migratory fish at different regions in the globe. So basically, we got data from the LPI, which is the Living Planet Index, which is an initiative led by WWF, and we got data from that data set, and we then looked into species that were classified as migratory fish within the GROMS, which is the Global Register of Migratory Species. And based on that, we looked into populations that were assessed since 1970s to 2016, including existing populations that were in that database for a long time, up to 48 years, and new populations that were included more recently in the database. But also, for some of them, you have data for up to 50 years as well. So by looking into that data, we got some astonishing results and alarming results that I want to put forward here, which shows that the majority of the fish, migratory freshwater fish in the globe, they are in severe decline. So we are talking about an average decline of 57%. And that decline changed across decades from 1970s to 2010, with the highest decline being observed then in 2010 onwards. And obviously, there are limitations to the data set. There are bias to the data set, and these are all discussed in the report. And maybe these increase in decline that we registered for the last decade, could be related to more availability of data and the subtraction of some species from the data set, from the data set in the end. But more importantly is that we then looked into trends, global trends, and the global trend showed that, if you look at the average and then you see the white line is the average decline, and with the bootstrapped confidence intervals, and one would be the optimum population or the initial population from the 70s, and then from there you'd see that we recorded about 76% in abundance, with change and reduction in abundance since 1970s, and this decline has been fairly consistent until mid-2000s. Then if we look at Latin America, which is one of the focus of this workshop here, we can see that the assessment of about 80 populations of 46 different species showed an average decline of 84%, which is quite alarming. Just to put into perspective, in Europe, this average decline was reached 93%. But then when we look at the conservation status at different countries in South America, and we look at Brazil, for example, we have now recently, the last assessment of threatened species showed about 312, and this is not only migratory species, this is all freshwater fish in the country, and that accounts for about 10% of species, migratory species that might be threatened. If we look at Argentina and Paraguay, then we're talking about 11 threatened species. And if we talk about Colombia, for example, from the last assessment, we're talking about 53 threatened species. If we put this into perspective, we're talking about 4 to 10% of all freshwater fishes from South America under a certain threat level. In a global perspective, Europe had 37%, North America 27%, and Africa 27%. So you can look at this data and say, okay, so South America is not doing that bad in terms of number of threatened species, right? Because we have the lowest rate. So why is that? Why we are getting into those figures at the moment? And again, to put into perspective, I believe this is a lot related to the fact that we still have some pristine areas in different locations. We still have a lot of development going on, so not all of our freshwater ecosystems are endangered or are altered. And if you look again into perspective back to Switzerland, and that's a scenario in Switzerland, out of 66 species, almost all of them are under a certain level of threat. And that represents the level as well of development within the country. So all freshwater ecosystems over there have been altered to a certain degree. And that led to 7 species that are already extinct in the country. So although we do have those figures like I showed before, like comparing to more developed countries, we have to raise a red flag here and show that, you know, we want to halt this decline to a certain degree, because otherwise, you know, there's a risk that we would go into getting some extinctions or having some extinctions later in the process. And here in Switzerland, almost all of these fish that I'm showing here are migratory fish. So that shows how the level of risk that they are. Now, back to threats and to the index, and assessing some of the threats through the index, looking at the population information and what's available out there. Linked to those populations, we recorded about 414 threats. Almost 50% of them, as you see in the graph here, represent habitat loss, alteration, or degradation that are associated with these uses here, and that's very common. We all discuss that quite frequently. In Latin American and Caribbean, these two threats, habitat degradation and habitat loss, accounted for approximately 40% of the threats, and then over exploitation was a very important threat as well in this region. And also another assessment that we did was related to management and how those populations were managed in the end, showing that to a certain extent globally, those are global trends. Populations that were managed to a certain extent, they had a smaller rate of decline compared to those in this graph here that were not managed at all. So we are talking about a 54% decline rate for managed populations compared to 87% of non-managed populations. But how management is done, like if we look at fisheries management and habitat management, you see that the majority of fisheries management here is totally focused on managing fishing activities, right? With habitat management, including some of mitigation measurements and other management actions that we have associated with barriers and other structures in the river. Now, can we say that management is effective then, or do we have management pitfalls? And that's where I want to bring you to one point, which I believe is one point of big knowledge gaps around the globe, not only in the new tropical region, but around the globe. So this is an example of a study that I had a chance to participate, showing these 3 different reservoirs here, and these are all small hydropower plants located in the Sapucaí River. That's the upper Paraná Basin. And then based on this, what we showed, or what we saw basically, is that adult fish, they managed to move through the fishways. All of these small hydropower plants here, they have fishways. So adult fish moved all the way up to spawning areas upstream, but during large events of large rainfall, and that's a relationship we see here in the graph, larvae and eggs, they were drifting downstream, and they moved downstream, with some of them, as you see here, being captured inside the fishway. But you see that the more downstream we go, the lesser is the density of these organisms captured inside the fishway, and that was associated with the fishway design and so on, which means that, you know, these larval fish and eggs, they went through the dam through a certain location. That could have been through the turbines or through the spillways, but at the small reservoirs, when we have large rainfall events and the flow increases, they can drift through and then can reach these downstream areas. And we may be moving adults all the way upstream to areas to spawn, but then eggs and larvae are moving back downstream and dying. So this is one point I consider is lacking in the literature and in the science as well. You know, the understanding of survival and mortality of these early life stages, understanding movements, and that's one focus I brought to Switzerland as I joined the group over there, and Australia as well. So I had the opportunity to join a few one PhD group in Australia, and that's the work done by Lorena, where she was looking into the behavior of larvae, 3 migratory species in Australia, and the behavior of larvae to understand whether the movements were passive, which is what we assume. And basically, she basically saw the navigation or the movements in this conundrum of active-passive to passive-active, depending on the flow regime, because you put larvae in this racetrack flume, and based on different flow regimes in the racetrack flume, you saw different behaviors. This one where the larva is active-passive, which means it's oriented upstream, but it moves at the same speed as the flow velocity. She saw also active downstream movement, where you see the larvae here, this little point here, and then all of a sudden it will turn around and burst and move downstream. So they are navigating this, it navigating these different flow fields, and actually at the certain flow conditions, being able to move upstream as well. So there is a lot of movement, there is capacity for these larvae to navigate different flow conditions. And this is one point we know very little, and we know absolutely nothing from the substance species, I would say, in terms of behavior of larvae. So taking those questions, we also moved forward, and we are applying some of those questions, trying to understand behavior of larvae in Switzerland. That's what our group in Switzerland is currently doing. And here I'm going to show you quickly some of the work that our PhD students are doing. This is a work done by Robert Now-Dasher, which is looking into hydropicking conditions and the effects of hydropicking in larvae. So Luz yesterday mentioned hydropicking. Today we had a few talks, and like Gordon mentioning hydropicking as well, which is basically this alteration in the flow fielding rates as the hydropower increases production, the water level table increases as well. And as it decreases production, then the water recedes and the fish has to move from those locations and relocate to different habitats to then avoid stranding and mortality, for example. So can they do that? And one thing that Robert is doing is putting fish in the flume and then having a vertical slope. So he developed this very interesting tracking system where we could track fish through this gravel glass and then have also some rugosity in the bed, and looked into the behavior of larvae. So that's a 40 millimeter larvae that would put in the flume, and then we track the behavior and we try to find what they were doing. So this is an example of what they did in the slow ramping rate, for example. So you see fish in acclimation, for instance, moving everywhere, and this is the water line, for instance. So this part of the flume is dry at low flow rates, and when the flow rate increases, this part of the flume gets wet and the fish can move up and down. So we were looking into how they behave when you have the peak, when we maintain peak flow, and when they drop down again. So basically, you see they were exploring as the acclimation, during the acclimation stage, as you reach a peaking stage, you'll see that soon, they all try to retreat, or they can't navigate, and they all retreat back to certain locations, and they find cover, or they find locations in the flume with lower flows. But more importantly, when you have the down ramping and base flow, they all relocate back to these areas that are wet, and none of the fish at these conditions got stranded. So if we look at what happened in terms of water depth change and the fish movement, we saw that there's probably a threshold. You see all these lines are fish movements, and you see that they are moving at the deeper areas, and then all of a sudden the area is getting shallow, and they move up, and they relocate to deeper areas in the flume. And apparently there's a threshold of about 2.5 centimeters of water level where this movement and fish going away is triggered. To finalize, going to the final deployment here, the other big knowledge gap we have is how these larvae moves in the field. So there's another PhD student, Frederick, working with this device, which is called RODI, and the riverine organism drift imager. And basically RODI is a device that is supposed to go underwater and work at different flow variations and get drift temperature and be applied at different temperature regimes and low temperature resolution to sample the drift of larvae and also invertebrates. And this is one experiment that he did looking into drift and emergence of trout at redds, spawning redds. And these are the images he gets. So you can't identify, you can't see anything in the image, but then you can process the image and slowly you will see some organisms moving through. So there's a brown trout larvae going through, and then with that you can quantify, you can certainly identify life stage and so on, and improve quality of monitoring for these systems. And lastly, you can use all of that information to advance models, which is another aspect that we are looking at with these two master students, Elian Duty and Joel Whitman, where we developed a tool, the Fear of Fish Escaping Route tool and fish pathways, where we're looking at what are the potential pathways with hydrodynamic models and also fish behavior models, integrating all of them to see how are they moving towards, source habitats to target habitats as the flow is changing in the water bed, in the watershed, due to different flow conditions, either because of hydropeaking or other situations. So to conclude, there's a clear evidence that freshwater migratory fish are impaired around the globe. We need to identify and we need to embrace solutions. Communication is needed, and we need to communicate clearly and resonate that mitigation does not necessarily aid to conservation. These are two different aspects. And weigh in as well the cost of doing nothing versus doing something when we need to solve problems. With that, thank you again for the opportunity, and we'll take any questions if we have time.
Thank you, Luis. You give us important information across the world. This is what we want to bring with the SHAASAN project, a global picture. And of course, we are worried about freshwater fishes, most important because we are dealing with fisheries and stocking for people. So we got two questions here in the chat. I will mix because it's related. They are related. So the question is, looks like is the assessment level globally standardized? Is how this assessment is standardized for species diversity across different countries and regions and data availability. And also consider, please, in this question, the new species that are commonly growing in South America compared to other regions as Europe maybe, or maybe could be similar in Asia. So please, can you give us explanation here? Thank you.
Yeah, so just briefly, and before I forget as well, like the LPI report is available online also. If you just type in, and I can, if you're interested, you can send me a message and I can send you a link to download the report. And then there you will see as well there are clear a description and information about caveats in the analysis. But basically, what we are dealing with is with a database that is global, and the analysis of the LPI index has been standardized, right? So we are doing that in a standardized format, but it is dependent on the feeding of the database, and the feeding of the database comes from all different parts of the world and all different scientists with different people and so on. But more importantly is once it's there, to be in the database, it has to be in a certain format that is a format where we're looking for standardization in the data availability. But obviously there are caveats, and one of the caveats that is the identification of migratory traits for these different species as well. And secondly, I think the answer is quite related to what I just said. Like, if we're counting for new species or not, this is also dependent on how well the database is fed. So if we go back to the map I showed, and you'll see in the report, there are regions in the world which is deficient in data. Indeed, like we need to feed the database with more data to be able to cover those regions. And these are all included in the caveats that we discussed in the report as well. So I'm happy to discuss that further with whoever's interested anyway.
Well, thank you, Luis. We appreciate your time for coming here. You give us a global perspective about this, so we appreciate it. Now we move to our next participant. He is Andre Castro. Andre Castro is a professor in the Department of Natural Sciences in the Federal University of São José del Rei. This is Brazil in Minas Gerais. He is specialized in ecology and behavior of neotropical sharks, race, and also fishes. Has expertise in molecular ecology, population genetics, phylogeography, and non-destructive methods for studying fish, among other biodiversity aspects. Thank you, Andre. The floor is yours.
Thank you all for the opportunity to be here and being in the same floor as you. And also I'd like to thank Luz, all the team for organizing this meeting, and also the SHAASAN team. It's a great opportunity to be here and also to be in Colombia. So today I'm going to talk about fish mortality by hydroelectric power plants and the search for co-creative solutions. It's not an easy topic, that's why they left for the last talk of the day. So I'm going to be very telegraphic because of the time. I have to start saying that I live in Brazil. Brazil has the largest number of species of freshwater fish in the planet. So a lot of the species means a lot of people that depends on the species, that rely on the species to survive, rely on species to make some living. And also we have a lot of power plants, which means that eventually we're gonna end up with a problem of fish mortality. So what I call fish mortality is important to say. It's a massive number of fish that's killed as a consequence of hydropower generation. And this has to be very clear because we saw on Raquel's talk, she was talking about fish kill. And here we're talking about a large number of fish. And I believe that's a problem, even if it's not a large number of fish is killing. And the question is, how big of a problem is fish mortality in Brazil? That's a simple question with a very complicated answer. And the reason is because of the lack of official consolidated data. So everything that we have are scattered information from different locations, from different power plants. And we have some information on the river, and sometimes we have information on biomass. We have information on some species, the main species that were affected, and also some information on finds. That led us to produce a report to talk about fish mortality by hydroelectric power plants. That was championed by Luis Silva, which is right beside me, and also Paul Kemp and myself. It was a great opportunity to work together with all of the support from the CEMIG, which is the Minas Gerais state agency to fund research, and also the British Council. And in that report, we kind of use one of the informations that is quite available in terms of fish mortality, which are information from the news. The good thing about fish dying, and please be careful when you say good thing about fish dying, is that they float and they smell. So when that happens, the population, they usually report those mortality. And the reporting of those mortalities is also picked up by the news, and we sometimes have more information on the news than we have official information. And that led to a study where we try to estimate the amount of fish that's been killed in Brazil for the past few years, and we're talking about 128 tons of fish being killed. That's not a very small amount. We also found something that's quite interesting, which is the fact that the events happen in pretty much, at least the most of the Brazilian river and basin. So we're talking about the entire Brazil, fish are being killed by hydroelectric power plants. And also, it's quite important to mention the amount of money that's being fined by the company, the industry. We estimate over 100 million US dollars in fines. I'm talking about fines alone. I'm not talking about the amount of money that are not making whenever they have to stop operation. And the other thing that's quite interesting, especially for us, is the fact that the bottle trauma was one of the most relevant injury, most prevalent injury found on those events. And I don't know if you guys are familiar with bottle trauma, but we're talking about bottle trauma. Bottle means pressure, trauma means injury. There are injuries that happen when the fish is, or something has to do with the change in the pressure causes an injury. And now we're talking about fish. So the bottle trauma happens with fish when it passes through a turbine. I'm gonna ask Luis just to point the fish passing through a turbine. You see that the pressure starts to increase, and then when it goes through the turbine, there is a quick depression on the pressure. There is quick reduction in pressure. Since fish, especially for the species that we deal with, the neotropical species, they have a swim bladder, they have a gas bladder that helps them to compensate with the depth, adjust the depth. The swim bladder is full of gases. So whenever we have a reduction in pressure, that means that the gases are gonna expand, which means that the swim bladder is gonna push everything that's around it. And that causes most of the trauma. So here are some examples of trauma caused by the swim bladder pushing everything around. So we have like stomach going out of the mouth, we have intestine coming out of the anus, and also exophthalmy, which means that the eye pop out of the eye sockets. But there is also another thing that happens with gases when we decrease the pressure, which is the solubility also decreases. So when you open up a can of soda pop or beer, you can notice that all the bubbles coming out of the liquid. That also happens with the fish, and that causes the injury that we call emboli, which is pretty much bubbles forming everywhere in the fish. And in the lab, we have the capacity of try to emulate or simulate what happens to fish when passes through different variation in pressure. And we do have this, what we call hyperhypobaric chamber. And the idea of this chamber is that we can put the fish inside, set to a certain pressure, leave the fish to accommodate to get the neutral buoyancy that they need to swim. And then we decompress the chamber, which means we decompress the fish. We take the fish out, we euthanize the fish, and look into different kinds of injuries. And we've been doing that for the most number of fish that we can get hold of. And the idea of doing this experiment can be seen as first of all, evaluate the susceptibility of neotropical fish to bottle trauma, which ones are more susceptible or not, to evaluate the effect of different rate and ratio of pressure change. And we talk about how fast the compression happens, or the amount of the compression change in pressure is going to happen. And also evaluate the different activity patterns and water use. For instance, there are fish that likes to stay in the bottom, don't use the swim bladder to keep the buoyancy. Are those fish less infected as compared to the ones that live in the water column and needs to have the swim bladder full all the time? And also we are starting to look at life stages. And so I don't want to go over much of the data because we don't have time, but he's just to give an example of what happens with fish when they are decompressed. We did an experiment recently with 2 species of carissids, and those are the kinds of trauma injuries that we find. So you see lots of bleeding, hemorrhage, we see lots of emboli, and also we see the swim bladder rupture, the expelled stomach, some coming out of the mouth, and exophthalmy. And I just want to point out, see the stomach out of the mouth of a fish, it's quite scary. But the bleeding and also the emboli, those are the ones that concerns us quite a lot, because we don't see that often when we look at the fish. And we also can show you that we have increase probability of injury as with the ratio of pressure change. And we did an experiment recently with the fish that is showing some of the bleeding. That's one species of caracids. Lots of bubbles forming on the fish, and also the exophthalmy. But can fish heal? Because we see those small little things. That's very hard to look into the field and into the fish when we're in the field. And we keep saying, oh, since we euthanize the fish right away when you're doing the experiment, what happens if you keep the fish alive? Is the fish able to heal and to survive? So we did the experiment with that species, and we kept that species for 5 days. And you can see that the probability of survival drops quite drastically with the ratio of pressure change. And so these are a few information that we have, but there's so many fish that are probably threatened by power plants, and we don't know nothing about it. So the whole point of this talk was to discuss actually the solutions for fish mortality. Are there solutions? I mean, obviously, but we have to remember that the problem has to do also affects the society and the industry. Some people could argue that the problem is even greater to the environment than it is for the industry, the same as for the society. It's much greater for society than it is for industry. But we have to because in the industry, they can compensate the amount of money that they're not making and charge us more. So, but the problem is it worthwhile for hydropower plant companies to invest in solutions to the problem? Yes, we say yes, because they are eventually saving some resources, improving the company image, and Raquel told us a little bit about that. More transparent channel with environmental agencies, and also a greater potential to attract investment for external financiers. So the solution has to come from the society, means the academia as well, but also from the industry. There are many challenges for the solutions. I'm not going through all the challenges, but I wanted to point out one that we decided to embrace, which is engaging all the players to finding solutions. And that way, we decided to promote an event about fish mortality. There was an online event. We used all the platforms that we could use to bring people to the discussion, using social media and everything that we could. We had a fantastic turnout. More than 4,000 people visit the website of the event. We have more than 800 people registered for the event. The average number of people participating on the event was about 450, which was fantastic. People from different countries, people from different backgrounds. We had biologists, we had students, we had people from the academia, researchers. I mean, there was a fantastic event. But the cherry on top of the cake was actually the workshop that we did the day after, because we could bring together players. And when I call players and call the academia, a lot of some of the researchers that deal with the problem, we call people from the industry, we call environmental agencies, state and federal level, we call the judiciary, a lot of people that deals with laws and making laws and how to read the law, environmental consultants, ONGs, and we had a huge discussion. And actually we brought to them a challenge. And one of the challenges was very provocative, was how to reduce fish mortality event at 50% by 2025. They got scared, obviously, but that made us think about a lot of things and try to come up with the ideas. The ideas were run in terms of the impact of those ideas and how feasible those ideas were, and trying to mess up with all this information, we come up with 4 important things, which is increasing research and funding, articulation, engagement, training, empowerment. That's very important, and legislation and regulation. That is just to show you that we could, using this kind of workshop, you could come up with some definition of actions of priority. And we had some of them. I'm not going through all of them. So we have research, articulation, environmental licensing, legislation, training, data gathering, planning, so on and so forth. For each one of those, we brought up a lot of potential to actions that could be made. And there was, next please. There was a lot of work, and we are trying to finish up that document as probably a suggestion for a plan of action in Brazil to deal with fish mortality. But just to finish up my talk, I want to show you some of the recommendations that we had in the report and also come up with that. First of all, funding and development more research in this area. And this is very important because we're dealing with in a country that the funding for research has been cut quite a lot. So if in general research is being kind of squeezed, imagine for this specific area. We need to invest in technology, in training specialists, people that knows how to do, sensitize, I know that I will get to that word, everyone involved in the problem. We're talking about hydropower plant workers. Those are very important to be sensitive to the problem. Also environmental agencies and communities. And for the last thing that I want to say is predict, plan, and quantify environmental impacts at all stages of hydropower plant projects. Probably Luis is moving the slides for me, but he'll write a lot of questions, so he could answer the questions, because this is a topic that is very sensitive to it. So I finish just presenting that. I want to thank everybody that's been involved in this kind of work that we did, all the financial agencies. And next slide. I also want to invite you guys to follow up our Instagram account, because that's where a lot of people got together, and that's probably one of the tools that we use to gather people to discuss about fish mortality. And especially I want to thank my students that are following us on this meeting from Brazil. Love you guys. Thank you.
Thank you, Andre. Your research program is very important to show us how hydropower can affect fishes, and knowing that South America holds a very important number and morphology diversity in fishes. Your research is very helpful for understanding these issues in the industry. So we got time for one question. The question is, considering the morphology and the diversity, there are species that are more suitable of having those problems you show us in the picture, or not?
Well,
thank you.
Thank you for the question. We believe so, and that's why we're trying to test as many different species as we can. And I mean, for instance, we have 2 groups of species that we have to face, which is the Physoclus species and Physostom species. So there are species that they have that connected swim bladder to the esophagus, which means that they have a channel where the air could be just released whenever the swim bladder is expanding. And there are the ones that don't have this channel. Right. So what happens to them? We believe that those are the ones that are going to suffer the most, the ones that doesn't have the pneumatic tube, what we call. But sometimes when you do the experiment, we see something that doesn't go with what we believe. So we have to test as many species as possible. We have to test not only for morphology, use of water as well. I mean, there are fish that seems to be especially vulnerable to those changes in pressure, but the way that they use the swim bladder not necessarily represents a risk for them, because sometimes the swim bladder is not full of air. So if you have a decrease in pressure, you have expansion there inside of the swim bladder, doesn't affect them as much. So yeah, there are so many things that we need to look into it. Thank you for the question.
Thank you, Andre. And now we got time to pass the participation to our host, Luz Segura. She will give us some considerations about these 2 days of working with our symposium of challenges in environmental sustainability for hydropower business. So thank you, Luz. Now the floor is yours.
Thank you so much, Hector. This is some time that we had been waiting for.
La posibilidad de
For
encontrarnos
quite a while,
físicamente.
we were
Llevábamos ya 2
talking
años
about being able to get together in person.
aislados y
We were
viéndonos
in
virtual.
isolation for 2
Y
years.
realmente después de estos 2 días de trabajo,
And
estas
after
2
these
tardes en que
2
estuvimos acá
half
hablando sobre
days where we
sostenibilidad
were here
en el
talking
negocio de la
about
hidroenergía,
environmental
vimos
sustainability
casos
in the
a lo largo
hydropower
del mundo,
business. We
¿cierto?
were
En
able to
donde
see cases
realmente la
around
gran
the world,
conclusión es que
and the biggest
las
conclusion here
hidroeléctricas no
is
son el único
that
problema que están enfrentando los
hydroelectric
peces.
power
Eso es lo
plants are
primero.
not the only problem
Que
that
hay que
fish are
buscar
facing.
soluciones
We
además
also need to
asociadas
find
con el
solutions
manejo
that are
en
linked
comunidad,
to
no solamente
community
las
management,
personas que hacemos o que
not
generamos
only those of
conocimiento,
us who provide
generando
knowledge
conocimiento solo por
or create
generarlo,
knowledge.
sino también convocando
We need
a
to
otras
call and include
instituciones
other
y partes de la
institutions
sociedad
and
para poder participar de esta toma de
groups of the
decisión.
society to
La
participate in the
conferencia que dio
decision
Paula, a mí me
making.
encanta ese título, entre
Paula's
más conocemos,
conference is great
más nos
because the
damos
more we
cuenta
know, the more we
de la
realize
importancia y la necesidad de conocer
how
más y de lo
important it
frágiles
is
que
to
son los
know more
peces
and how
ante los
fragile
cambios que
fish
nosotros generamos en las redes fluviales.
species are.
Entonces, este momento para
So,
nosotros como universidades, porque todos
in
aquí
our case, as
representamos a
the university,
universidades, a
because here we are all
instituciones
representing
y a empresas del
institutions and
sector eléctrico,
universities and
en donde nos sentamos acá 2
energy
tardes a conversar
businesses,
sobre
we
las
sat
posibles
here
alternativas de manejo.
together to
Y
talk
si uno
about
se
the
pone
possible
a considerar
alternatives.
todo lo que hemos presentado, es
And if
mucho lo que
we
falta,
consider everything that we
sobre todo en las
presented,
regiones
we still have
tropicales
a
en donde
long
la
way to
diversidad
go,
de peces
especially in
es tan
tropical
elevada.
areas where
Entonces,
we have
es un llamado
where the
a
diversity
que
is so high.
continuemos
So
con esta estrategia de seguir
I
trabajando. Tenemos el
encourage you to
apoyo
continue
invaluable
your
de nuestros
work.
estudiantes, de
We have the
nuestros
support of
chicos
our
que están siempre
students
trabajando con nosotros
who are
y
always working
acompañándonos
with
en la
us.
construcción de conocimiento. Y hay algo que
Together
tenemos que
we are
abordar y es
working on
cómo
building
llegar
more
a
knowledge,
las
and there's
autoridades,
something that
cómo
we need to
llegar
address,
a
how
esas
to approach
personas que
the
en cada uno de
authorities
nuestros gobiernos son las que toman
and
la decisión.
the
Son
decision
las que
makers,
definitivamente definen
because they are the ones
qué
that
es lo que van a
define
hacer.
what they're
Si
going to
van a
do.
construir o no un embalse, si van a
If a
construir o no
dam will be
un embalse,
built,
cómo lo van a construir, cómo lo
how
pueden
it is
construir
going to be
para
built
reducir el cambio que se
in
puede
order
dar
to
en las
reduce
cuencas.
the change in the
Entonces,
basin.
como universidad
So
hospedera, la
as
Universidad de
the
Antioquia,
hosting
les agradecemos
university,
mucho haber venido
we
acá, haber
thank
hecho el
you for your
esfuerzo. Hay
presence.
personas que vienen
I know
desde
that some
África, hay
people came
personas
from
que vienen desde
Africa,
Chile,
some people
en
came from
Brasil,
Chile,
son distancias
Brazil.
muy largas.
We know that these
Inglaterra.
are very
Entonces,
long
este es el esfuerzo
distances,
que se ha
even
hecho de
people from
manera muy
England.
importante.
So you have made
Hay
quite an effort.
universidades que
There are some
participaron en la, digamos, en
universities
la
that
organización del evento.
participated
Está el
in
Ministerio
the
de Desarrollo
organization
Sostenible del
of
Paraguay,
the
está la Universidad
event.
Southampton.
The
Tenemos quienes nos
University
financiaron,
of
la
Southampton.
universidad,
We also
la
have the
Royal
funders,
Academy of
the Royal Academy of
la Royal Academy of Engineers.
Royal Academy
Los
of
otros nombres son
Engineers.
la de ciencias, no, de salud.
It's a global research fund And the medical sciences.
Sí, y también empresas públicas de Medellín.
And also
Y todas las
EPM,
instituciones
and all
a
the
las cuales
institutions,
pertenecen cada uno de ustedes y que les
you
permitieron
belong
venir acá
to, that allowed
para
you to
poder
come
trabajar
here
en conjunto.
to
Mañana
work
vamos a tener
jointly.
el tercer
Tomorrow,
día, que
we will
nos vamos
have
a
the
concentrar en
third
una de las estrategias de
session.
manejo,
We will be
que
focusing
es
on
la
one of the
favorita
management
por la gran
strategies,
mayoría
which is
de
the favorite
entidades
one.
que deciden sobre la gestión de los ríos, y es los repoblamientos. Hay
Stocking.
en toda Sudamérica, y yo creo que en todo el mundo,
Across South
una
America, and I
duda
think across the
creciente sobre la
world,
efectividad real de un repoblamiento. Y
we
yo creo que
keep
este escenario
wondering
es
if
perfecto
the stocking
para conocer
strategies
experiencias. Vamos
are
a tener
efficient or not.
el
So
punto de vista de
this is
Angelo
the
Agostino,
perfect
que es una persona
scenario to
que
see some
conoce muchísimo de
experiences.
embalses y que también conoce
We
mucho de
will hear
repoblamientos.
from
Y también
Agostino.
vamos a conocer experiencias que se han dado en
He is an
Colombia,
expert in
temas
stocking.
como
We
de
will also
genética,
hear
como
from
la importancia,
experiences in
el
Colombia,
impacto que tienen los
the
repoblamientos en la
importance
genética de
of
las poblaciones.
stocking in
Entonces,
the
para
population
nosotros,
genetics.
ha sido un éxito
So
este
this has
encuentro.
been a success, this
Sabemos que
seminar.
vamos a seguir
We
trabajando porque
know we will
nosotros no nos
continue to
conocemos de ayer,
work
nos
because
conocemos hace varios años
we've
y
been
hemos
working
trabajado
together
en
for a
conjunto.
few
Sé que vamos
years
a
and
seguir
we've been
trabajando.
working jointly, and I know we
Lo
will
importante
continue
es
to do
empezar
so.
a buscar más
What
recursos
matters
para
now
poder
is to
hacer
get more
cosas más en
resources in
conjunto,
order
¿cierto?
to
Y yo creo
undertake more
que la colaboración
projects
entre nosotros
together.
es fundamental.
And I believe
Entonces yo
that
sé que vamos a
collaboration is
seguir,
key
ahora que ya
here.
estamos disponibles para
So
viajar,
now that we
podemos
can
ya viajar
travel,
entre los países y podemos hacer más
we
colaboraciones.
can do more collaboration
Quiero
work,
entonces cerrar
collaborative work.
este día de hoy
I
con
would
ese
like to
agradecimiento a todos
close by
y
thanking everybody,
invitarlos al día de
and I
mañana.
want
¿Cierto?
to
Yo sé que Barranquilla es
invite
maravillosa,
you
todos se quieren ir a conocer
to
Barranquilla,
attend
pero sería
tomorrow's
muy bueno que nos
session.
acompañaran mañana.
I hope you can be with
Y
us
no sé
tomorrow.
qué otro, si alguien quiere dejar algún
And
mensaje
I don't know if
para
anyone
cerrar
else
ya el
would like
evento.
to send another message to close this event.
Thank you for your words. I just want to express from SHAASAN that we are very happy to be here and working with you. And I would like to express a recognition of you and also the Ichthyologists for hosting us. So I propose a big applause for you. There is a suggestion of putting their cameras on and just to having a picture here. Who will check the picture? You can do it, Luis.
I want to
Y
thank
a su
Sarah
esposo que nos
and
acompañaron
her
durante estos
husband
2 días.
who were
Mañana van
here
a
with
seguir.
us. Tomorrow they will continue to be here.
Y al equipo de la universidad que desde
And
Medellín está en la
the
plataforma Zoom con los
university's
traductores,
team
muchas gracias por estar aquí.
who also
Fueron
provided
de
the
mucha ayuda
interpretation.
porque
Thank you so
permitieron
much for
que
being here
esto
because
fuera
you
realidad y que
allowed us
pudiéramos hacer el
to
evento de una manera
make this
más
a
amplia,
reality,
internacional. Hay mucha gente
and
asistiendo
we were
alrededor del
able
mundo.
to have an
Entonces, muchas
international
gracias por el
event.
apoyo.
Thank you so much
Ahora
for your
sí, la foto.
support. Now let's take the picture.
You got it. Thank you.